Welcome to this webinar. Today's topic is how to identify 3D printing opportunities on your shop floor. If you follow the 3D printing news, there isn't a day without a new interesting 3D printing application. But how do we know which applications are the most relevant for your business? In this webinar, we will explore one methodology we use at Blueprint with our client to identify which opportunity will have the most impact on their business. My name is Loic Le Merlus, Consultant Manager at Blueprint. I spend most of my time working with our customers from various industries, analyzing their order data, the inventory, and processes to evaluate and identify where in 3D printing can add value to their supply chain. I have a long expertise in building cost model and our proprietary software tools necessary to carry such analysis. Where should you be starting to look at 3D printing opportunities that can help your business to run more efficiently? Here we are looking for tooling equipment, jigs and fixture, and effector, assembly aids, and other tools that help you creating your product, as well as potential spare parts for your production equipment to keep your line running as smoothly and efficiently as possible. We observe that a lot of companies start by picking up parts and evaluate if they can be printed and if it will be cost effective to do so. There have been some successful case studies where customers managed to identify 1, 2, or 3 different parts that will bring them enough benefits to justify an investment into 3D printing capital equipment. This can work with enough luck and the right expertise, but in our line of work we don't want to rely on luck. And we want to have a reliable, repeatable process that can be used to identify hundreds of parts and not just a few. While picking up parts and evaluating their printability and the economic feasibility is a very critical step in the process, it is just one of the steps in a much larger process. So, even before looking at any part, we start deeply looking at the data. The purpose here is to identify the part that will bring first and foremost business benefits by using 3D printing. In order to do so, we look at order data, productivity data, failure and downtime history, and really any other data that can inform which part issues can be solved using one or several of the business drivers for 3D printing. For those new to our webinar and those unfamiliar with Blueprint, I would like to briefly describe our 6 business drivers. This is a fundamental methodology for how we understand and teach our client to understand the world of 3D printing and how it impacts and benefits businesses. So, what is it and how does it work? During our many years of consulting with industry partners, government agencies, and academic partners on 3D printing and additive manufacturing, we slowly began to recognize patterns. More and more of our recommendations, solutions, or results from academic work would touch on recurring principles. It seemed to suggest that there is something more fundamental under the surface, a bedrock from which all our work was sitting on. So we decided to dig down to bedrock. And after reviewing, critically comparing and codifying, we formed, or we could say discovered, the 6 drivers of business value. 6 fundamental and distinct principles for how 3D printing impact and add value to a business, industry, and the world we live in. If you haven't already, I would invite you to have a look at our other webinar from Blueprint, which goes deeper into those 6 business drivers. This can help you to follow on with this current webinar and understand better how we can help and how we think about how helping our clients of using 3D printing. Now, if you're familiar with our 6 business drivers, you can actually go deeper. For each of those 6 business drivers, you can go into more detail and more methodology on how to apply them. These are our 50 different tactics that represent how to use this business driver for 3D printing. In this webinar, we will focus on the application for the shop floor, principally around tooling, jigs and fixture, and spare parts. That leaves us with 22 different tactics across the 6 business drivers. That's still quite a lot to play on, and a lot of tactics that we can apply to find opportunities. For the next 15 minutes or so, I would like to go through one of the methodology we are using at Blueprint about how to identify spare part on a shop floor. Here we're going to use one example of a project we finished with one of our client with a big FMCG company. So think about a production line that creates millions of parts per week. The most critical aspect here is to minimize the downtime of the production line. Thereby, spare part management is critical and a very important cog in the machine. So how can 3D printing help them? We start by looking at all the parts in their spare part inventory. That's about 32,000 different SKUs. This includes a wide variety of components such as screws, buttons, wiring, solenoid and other electrical which are not suitable for 3D printing. So how do you tackle that? Unless you have an army of people who are available, it is not possible to go through them all by one, manually, each individually, to evaluate them for 3D printing. So we need to narrow down the scope to be easily manageable. So how do we help our client to reduce the scope and only focus on the part that are the most likely to be suitable for 3D printing? We start by a set of interviews with key personnel. It could be person from procurement, person from inventory management, person from production, person from quality management, all set of different functions that might have some influence and some knowledge and strategy around the spare part for the production line. Now, through those interviews and through our discussion, we're able to narrow down the area where 3D printing can bring business benefits. That's really the first way to narrow down. Let's focus on the area where 3D printing can have the most influence based on the way the company is already set up. So in this particular example, we decided to focus on a certain type of supplier which provide only machined component. That allows us to eliminate a lot of off-the-shelf components and electrical components that wouldn't be benefits to use 3D printing for, and that will be economically not viable for 3D printing. This process really allows us to focus on where the benefits will be the most important. In this example, we go from 32,000 parts to about 1,000 parts. This is way more manageable, but it's still too big for a manual review, so how can we go a bit further down? So, in order to narrow it down even more, we look through 5 years of orders. So, looking through the last 5 years of all the spare parts that have been ordered for the supplier that we have selected, this allows us to look at order pattern, cost, variation, to focus on the part that have the most trouble. Let's look at, for instance, parts that have unreliable supplier, that have a sole supplier issue, that have a lot of demand variation, or that are very seasonal. All of that allows us to see, by using 3D printing, what are the parts that will get the most benefit, and where 3D printing can be of the most help. After doing all our focusing and our data analysis, we are left with about 150 different parts. This is great. This is a good number that is really helpful and that you can look through manually in a limited amount of time. So let's see if those parts can be substituted by 3D printed parts. Before we finish the preparation stage, there is another filter to run. Let's look at all the part description, part categories, or anything that can inform us on what the part is and what is its function. That way, we can filter more easily on what are the ones that is traditionally the most suitable for 3D printing. Through all our experience, we have categorized what type of parts usually tend to be more suitable for 3D printing, and that's where we will focus on. Let's look at brackets, rails, pusher, plates, small assemblies, all of those type of parts that can be more easily replaced by 3D printing. This leaves us with about 100 different parts that we can go and see visually, because only once we see them we will know is this a good part for 3D printing or not. Now it's time to go on site and have a look at parts. This is a critical part of the process, like we said earlier, and that's where people usually start. But here we already have hundreds of different parts, so that are ready for us to look at when we get on the site. Here we're saving a lot of time and a lot of energy by only focusing on the parts that are the most likely to bring benefits. So we look at those parts and we review what's the material, what's the size, what are the shape, is there any fine features, is there any complex geometry that 3D printing will bring a big advantage, and more importantly, let's look at those parts in situ. It's very important to know and look at the part and see what has they been used for, what are the type of loads on it, what kind of environment they're in, is there some corrosive liquid that's in contact with, all of those kind of information that are important to make a decision, can we transition the part to 3D printing. In the case of our client, for this particular project, we actually seen that about 50% of the parts that we want to see were suitable for 3D printing. This is a very surprisingly high number, and that is very encouraging for the rest of the project. Once we notified the part that seems to be suitable for 3D printing, it is important to group the part by families. Let's look at in all the ones that are suitable, what do they have in common? Are we having a lot of pushers of the same material? Are we having a lot of parts with the same size? It's very important to know which category the part belongs to, because it will be representative of larger set of parts. In our previous filtering, we only looked at a certain number of parts, and we discard some of them that might not have the full economic benefits on their own, but if they're part of a bigger family, they will bring bigger benefits, and all those benefits can be added up for the transition to 3D printing. That's why it's very important to look at and create families of parts that are suitable for 3D printing, and then for each of those families, get a representative part for each category to do a deep analysis on. Because we can't do a deep analysis on every single part, this will take a very long time, it's a lot of effort. So it's important to have our part grouped by categories and families of very similar parts that have the same material, same functionality, same size, same cost, and then take a representative part for each of those families that you can do your deep dive on. After we look at all the parts, we created 35 different categories. For each of those categories, we kept one representative part that we can do a deep 3D printability analysis on. In this step, that's where the collaboration with the client is the most important. Here, we get all the 2D and 3D drawings to get all the different requirements for the part. That could be tolerances, loads, and environmental requirements. This is in order to evaluate if 3D printing can be a solution, and if it is, what is the best material and what is the best 3D printing process to achieve those requirements. This requires some back and forth with engineering and quality teams of the client. In our particular example, once we looked at all the 2D and 3D drawings, we realized that about 80% of the parts were printable, and we had the suitable material and process for them to be printed. That's about 28 parts that we know are technically feasible. Now let's look if they would be economically viable. Because here we're only looking at spare parts, it's very unlikely that each individual one of them on their own will have enough demand to be viable economically to make a 3D printing investment. That's why we looked at all of them together to look at all the demand of all the parts in all the families together to simulate what a real machine utilization would be. This is done in order to evaluate what machine size would be needed and how many machines of the different technology would be required. Based on this simulation, we can accurately predict the manufacturing cost of the 3D printed part. This allows us to filter the part that would be cost effective to manufacture using 3D printing, and we run this simulation multiple times on the parts that are cost effective to get the most accurate machine utilization figure and thereby the most accurate manufacturing cost. The most accurate simulation that we ran on this particular scenario estimated about 37% of saving for the 28 representative parts that were printable. This is not by all means a small saving, but it is limited at the moment only to 28 parts. Let's see if we can expand that. The last step is to expand the result to the other part in the category. Because we created those categories by material, size, functionality, and cost, the printability and saving will be very similar to the other part. On top of that, we add what we call confidence level. For each representative part, we give a percentage of how likely the parts in the same category are similar. This allows us to have more accurate data. So going back to the order history, we can predict exactly how the demand for parts will ramp up as the stock gets depleted, and pinpoint as to when machine investments are needed to meet the part demand. At the end, it was estimated that 3D printing can be around 22% saving on the 1,000 machine parts that were ordered from the selected supplier. This is taking into account the saving for our representative part and our confidence level for each category. This saving only occurs once we are at full production, as it takes some time for the current stock holding to be depleted and 3D printing fully replace the current methodology. As an example here are the machine utilization and the addressable number of parts for each machine. We can see that even at low utilization, using a metal powder-bed machine is still cost effective compared to the traditional manufacturing. If more metal parts were to be identified, then the saving for those metal parts that are already been identified can be largely increased due to higher machine utilization. Alternatively, it might be preferable to use a survey bureau for such a small amount of parts, thereby not having to make the initial capital investment into the machine, but it might be more costly in the long run. We have seen here one of the methodology we're using to identify the opportunity for 3D printing and quantify them. Through this process, we only looked at a small area for all the potential benefits of 3D printing. We only look at part of manufacturing and part of the assembly, not even the whole possibilities there. Through the last 15 years, we have developed a wide range of different methodology to assess the different part of your company. We can look at your engineering and innovation process. We can look at your prototyping process and more around your distribution or even aftermarket process. And before we leave, I would like to mention that if you want to know more about our 6 business drivers and all the tactics that go with it, you can download our latest book, The Little Blue Book of 3D Printing, by visiting our website additiveblueprint.com. This is a great little pocket book if you're ever stuck for understanding how 3D printing could benefit you and your business. I promise this would give you an endless inspiration for you and your team thinking. It goes into detail about all the different tactics to apply your business drivers and give an example for each and every one of them. To wrap up this webinar on how to identify 3D printing parts on your shop floor, I want to say thank you for spending the time with us at Blueprint to listen and to hopefully learn something new. It has been super fun to present this. I really hope you attend the next episode, and if you want to carry on the conversation, then email me at hello@additiveblueprint.com. If you are already on a 3D printing initiative, then I would also love to hear what you're doing and how you are going about it. With that, I will sign off. I've been Loic Le Merlus, lead consultant EMEA, and I shall say goodbye and thank you, and I'm really looking forward to seeing you at our next webinar.